Welcome to another tutorial from Master the Oracle. For more tutorials, see our website at www.rcoracle.net. Also make sure you sign up to our newsletter, Oracle Tips and Tricks. So just go to rcoracle.net, oracle-tips-signup.html and enter your name, your email address and your name and subscribe, and that's it. You'll be added to our list and on the list for updates to our tutorials. Tutorial, we're going to look at the use of explain plan for displaying the execution plan of our SQL statements. And this is a very important part of SQL performance tuning, because if you don't know what your SQL statements are currently doing, you don't know how you can improve them. So we'll start with a very simple query. Just select the last name from employees. So how do we generate the plan? We just prefix our query with explain plan for, and then we run the statement. That generates the plan. We switch to this other window here and we display the plan by selecting the output from dbmsxplan.display and converting it into a table so that it can be recognized by SQL. And the thing to look at is when we're looking at an plan table output is that we read it from the inside out and the bottom up. So the first operation in this plan for this statement is to scan the employee name index, and that's the only operation. That's the parent of that is the select statement, so the index full scan is the only operation. The reason for this is that the optimizer decided that it doesn't need to go to the table to get the data. It can get everything it needs from the index. Right, so we'll switch back to our other window and let's try a little more complicated query. We'll do a Cartesian join on the departments table. So if we explain this, or show you the execution plan for this, that's generated the plan. We switch over here to look at the plan, and here you can see that we're doing, well, one thing to look for is this merge join Cartesian. If you see that, you should check that you have included the join conditions in your queries. So because of that, it's going to do, well, it's still doing index scan, so maybe not too bad. But we haven't actually specified what the join condition is, so we need to do that. So if we go back to our query and specify the join condition, just alias the tables, and SQL developer kindly provides us with the join clause, so we can run this again to generate the plan, the execution plan, and then we can display the execution plan. So you might be surprised to see that there's no access at all of the departments table. And why is that? Well, because we haven't actually selected anything from the departments table. All we've done is select the last name from the employees table. So the optimizer has decided that it doesn't need anything from the departments table, and so thrown it away. But in this case, instead of doing an index scan, it has to do a full table access because of the predicate that we've added by default, which is that the department ID in the employee table cannot be null. The reason for that is because we're joining with the departments table, and we're joining on the department ID, and the department ID on the departments table can't be null by definition because it's the primary key. So we can now, if we add the department name into the query, the plan will change again, and we can see what it does now. So we need to extract the plan or display the plan. So it's doing a nested loops operation. So this is usually, or this is often done with OLTP databases. So it's joining two sets of data or two sets of rows. It has an inner loop and an outer loop. The rows from the inner loop are joined to those in the outer loop. So the inner loop will be the employees and the outer loop will be the departments table. So again, we're doing table access full on the employees table, and we're doing an index unique scan on the department ID, the primary key of the departments table. And the other predicate has changed this time, and now we're just saying that the department IDs have to match in both tables. So we'll switch back to our other window and make our query even, well, not even more complicated, slightly more complicated than it is. So we'll just change the formatting slightly so we can see what's going on. And we'll add another condition on. So we'll add a filter for the department ID, which is the maximum department ID from the departments table. And we'll generate the plan for that. And we'll look at the plan, see what we've got this time. So quite a different plan. So what have we got here? Well, again, we've got the nested loops, which, as I say, is for joins. So when we're joining two sets of data, and we have an index range. Well, the first operation will be the looking for the maximum department ID, which is obtaining by scanning the index. And that eventually feeds into this table access by row ID of the departments table, which will give us the department name. And those rows are then joined to the rows from the employees table. And it does an index range scan on the different index this time, which is the index on the department ID on the employees table. And it uses the row IDs then to get the data from the employees table. So we can tell that this it's accessing departments using that as the driving table rather than the employees table by changing the order, or changing the filter rather, the where clause. So if we say that the department ID on the employees table has to be equal to the maximum department ID from the departments table, and regenerate a plan and look at the plan that we just generated, we'll see that it's changed. This time, employees table is the driving table. Well, obviously after it's found the maximum department ID from the departments table. The tutorial was brought to you from asktheoracle.net. Remember, if you have any questions about Oracle at all, you can go to asktheoracle.net and go to Oracle questions and submit your question for us to answer.